were I muted? Yeah, I was muted. Oops. Did I? So, okay. Now I hope you, first of all, sorry for being a little bit late. And I just talked about that we're going to, in our following live castings, we're going to do, one day reading the manual, reading the Kotlin syntax, and one day coding. So we're because we have read a lot of materials yesterday, let's do some codings today. So this is the question we're going to solve today. The first question: avoid obstacles. You are given an array of integers representing coordinates of obstacles situated on a straight line. Assuming you're jumping from the point 0, you are allowed to make jumps of the same length, blah blah blah, and find the minimal length of the jump enough to avoid all the obstacles. So, actually, this problem is kind of hard to solve. It's easy to solve naively by just trying from step 1, 2, 3, 4, blah blah blah, and I can't think of an easier way to solve it actually. So another way that might be possible would be so the largest step that we can jump would be we can start from the largest plus 1. If we jump from 0 to 10 directly, and let's look at this graph here. If we jump from 0 to 10 directly, that's the largest, and we can start from 0 to 10 and 0 to 8, which is the largest, minus 1, and then we can find the okay, given that we're going to so if we take a look at the last coordinate, it is either from 10 or somewhere in between 10 and the last step. How can I express this properly? So that's I don't know, but I somewhat feel like solving it naively is the easiest way. So no matter what, so given the input array is not sorted, so basically what I'm thinking is all the methodologies I have introduced needs a sorted array instead, so we might need to sort it beforehand. But what if the most optimal solution is smaller than n log n, because sorting itself is n log n operation. So what is smaller than n log n is is basically a big O n solution, where it is definitely not possible, I believe, because by n it means that we after scanning every element in the array, we will need to already get the solution, which I believe is not possible. Is it possible? I don't think it's possible directly from the structure. I'm inspecting each of it, like the biggest, like the maximum, minimum, or average, or I don't think we're going to be able to solve this problem with that. We will at least need to compare between items, so that would be at least n log n. So it's safe that we can say that the optimal solution is definitely larger or at least n log n. So we can sort it. That's my belief. If you know it's not true, just let me know. So let's first sort the Kotlin. Wait, Kotlin sort list, mutable list. I believe it's just a sort, I guess. Yeah, it's they are extensions, so we can basically just simply do this. Input array dot sort. Guess so. Sort the array in place, so it's probably a merge sort or those kind of things. Yeah, it's sorted. Let's make really sure that we have already sorted. Create lawn. It's sorted. So for I n 1 up to input array dot length dot size -1 +1 var iclon equals to I. So this is basically an n square implementation, which could be not optimal, but I'm going to first solve it naively. So finding an intersect is itself too a big, I mean, because this is array list, or we don't know the implementation of the list, but because it's a list, it's probably needs on to find an element, so it's kinda not practical to do this. I am going to use another implementation, which is the HashSet. So is there mutable set? Kotlin, yeah, there's a mutable set. But I'm gonna use HashSet because we need these HashSet to be promised. Else, I don't think the add or whatever in it is find. Yeah, I think I need to find HashSet Kotlin. Is there such? Yeah. So is it going to talk about a complexity find? Well, it's not going to talk about complexity. So we only know about the Java HashSet then. Does it also not talk about the big O complexity time? In particular, it does not guarantee that the order will remain constant over time. This class offers constant time performance for basic operations: add, remove, contents, and size. That's why I'm picking HashSet to do the operation that I need, because we need the contents to be to be constant time. HashSet of int val set of type HashSet dot add all input array Does it have a max for HashSet? I don't think so. But we got while current position is smaller than or equal to input array. That's just called last element. Input array dot size -1. While current position is smaller or equal to last element, we need to check. If is there a label Kotlin for return add labels? So there is some label. Yeah, there is a return add lit. List of blah 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 for each, and we name it lit. How should I name that? Find step do I'll add? Oh, this is because it's a lambda. What about if there's a loop add? What? Why? Any expressions in Kotlin may be marked with a label, the form of an item followed by @, abc @ loop @ So yeah, we can use loop @ and break loop. Find step @ for blah blah and break. If what? Let's first write continue find step @ is that it? Continue @ find step. Loop @ okay, I think that's it. If current position set dot contains else we will, let's call it step then. If it has passed everything, we know the answer is step. Oh, a one-time solve. I am getting familiar with the Kotlin syntax now. Nice. Only 0% of users solve this task with the same language as you did. Yeah, I know. Kotlin is just so rare for now on task. What's the name of this? Task signal, code signal at least. Alright, then actually I kinda feel like we don't need the loop until last element plus 1 because we're going to return last element plus 1 here anyway. And we can use last element plus minus 1 because last element is definitely going to be not to be an answer. This is slightly faster, but anyway, itself is n log n here. N log n here for the sort, and n here for the addo, and then this is n times kinda also n, but it's actually slightly smaller than n, but basically this loop is still of the size n square because this would be n divided by this k here, so it's actually n times 1 n times n blah 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 plus n minus something and blah 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 1, so that is basically yet another n square. So maybe it's n triplet and cube actually. Is it? Could it be? So and this is n and this is at most n. So okay, no, it's just n square at most. So yeah, the algorithm here is overall n square. We might be able to find a better solution. I can't think of one now directly, but given that we're not writing coding practice, algorithm practice, we're just writing coding practice, I think I'm good at this solution already. So yeah, I think I've also I have stuck at somewhere that was I think I've stuck myself in episode like 18 or 16 to 18, and that was a nightmare where I was just dragging and wasting times for people who want to learn about Kotlin. So let's just stop here. Okay, so that's 9:30 already. Although we have started late today, but I think that's call it a day. And we can look at some other Kotlin syntax tomorrow. Maybe we can take a deeper look into this return and jumps control flows. Actually, I don't think that it's worth it. We can look at it now for a little bit. So you can name a loop and like break at a loop or return or continue at a loop at a named loop like we were able in Java. So we are also able to return at labels and like the lambda expressions. So we can return function at let's see. So okay. So basically in normal, note that such non-local returns are supposed only for lambda expressions. So this one is compile, no? Huh? What? Why? How? So for normal return, we return from the function. So that's why we don't need to want to here. But if we want to return from a lambda, which means skip this this iteration of this lambda, we can use this named label to skip it once, and it's also same as well for each and for each. Okay, so oftentimes it is more convenient to use implicit labels like for each and a return statement, and an anonymous function will return from anonymous function itself. What? Why? There's a function. Oh, okay. If we make it really explicit, there's a function. This is still going to be 1, 2, 4, 5. Yeah. And use of local return in previous three examples is similar to the use of continue, what, where, and regular loop. Yeah. There is no direct equivalent for break, but it can be simulated by adding another nested lambda. Where is that? Another lambda. Oh, okay. There's a run loop at. Okay, so it's returning at loop. So this would work like break, which is definitely the same behavior as the one when we label nothing, I guess. So it's 1, 2, yeah. But even it's 1, 2, it's not returning. It's not leaving the function directly. It's still coming back to these print afterwards. Yeah, because you would notice that here this point is unreachable and it's not printed. The parser gives preference to the qualifier return, i.e. Okay, this is something I don't really get it, but what it is trying to say is when parsing a Kotlin code, return at A1 is understand as return 1 at label A rather than return a labeled expression. I mean, I don't know what a labeled expression means, so that's why I'm kind of confused. So that's all for today. See you guys next time. Bye bye.